In question 7 of this series, I'll show you how to solve a static application word problem. Before we begin answering this, where we have to find force 1 and force 2 of these forces acting on this body, keep in mind that if a body or an object is at equilibrium, where it's not moving at all, it's referred to as being static. And it turns out that the sum of all horizontal forces acting on a static body is equal to 0. So if I find all the x components of these vectors and add them up, it should equal to 0. Similarly, the sum of all vertical forces acting on a body is equal to 0. So finding all the vertical components of these vectors should give me 0. And lastly, the sum of all moments acting on a body is equal to 0, where moment, represented by this equation, is equal to the force times the distance. Normally when we talk about force we use newtons, but here they're using pounds, and that's also a force unit, pound force. So don't get confused if you see pounds. What I'll do to find out what my F1 and F2 forces are is I'll create a table for all the x components of these vectors and a column specifically for all the y components. Let me show you what I mean. The table will look like this. X components, that's our first column, and our y components. Let's start by finding out the x component of this vector. The x component is this thing from here to here. I'll circle it. And remember, every vector can be represented as a right triangle. So this dotted line here would represent the y component of this vector, and this line over here would represent the x component. Using 51.3 as my angle, this line right here, this unknown force, is the adjacent relative to my angle. I have the hypotenuse, I'm looking for the adjacent, I'll be using cosine, because cosine relates the adjacent over the hypotenuse. So if I replace 1520 into h and replace 51.3 into theta, my angle, and I solve for a, I end up with 1520 times cosine 51.3 degrees. And it turns out that every x component that you find will always use cosine. Keep that in mind for the next 3. The y component, on the other hand, is this part. That's the opposite of this angle. Opposite and hypotenuse. Opposite and hypotenuse. What is that? That's sine. So to represent our y component, we'll take 1520 and multiply it to sine of 51.3 degrees. We just found our x and y components for this vector, and I'm going to go ahead and find out what these numbers are. 1520 times cosine of 51.3, that gives me 950. And for this one, all I have to do is replace that cosine with sine. And this gives me 1860. 1860. A lot of teachers will want you to consider significant figures, and if that's the case, you have to be extra cautious when writing out your number. For the sake of simplicity, I won't worry about significant figures. Next, I'll find the x and y components of this vector. This one has the unknown hypotenuse of f1. And also, if I find the x component of this vector, keep in mind that we have been given the acute reference angle of 41.5. And according to the cast rule, only cosine evaluated here will be positive, all will be positive here, only sine will be positive, and only tangent will be positive. So since our x component is defined by cosine, I'll have to make it negative. Let me show you what I mean. f1 is my hypotenuse, so f1 times cosine of 41.5 degrees. This is going to be negative because it's cosine in the second quadrant. Only sine is positive. Now notice the difference when we find the y component. The y component will be positive f1 sine of 41.5 degrees. Now you'll only worry about adding positives and negatives at the front of these expressions if you have the acute reference angle, to which we have in all 4 vectors. Let's find the x and y components of this vector. The x component will be cosine of 25.8 times the hypotenuse of 2,130. Since only tangent is positive here, this will be negative. And similarly for the y component, we'll have negative 2,130 sine of 25.8 degrees. I'm going to go ahead and find out what these numbers are by substituting them into my calculator. Negative 2130 cosine of 25.8. Make sure your calculator's in degrees. We end up with negative 1,917. And this evaluates to, I'm going to change this to sine. We get negative 927. For my last vector, once again, my hypotenuse is missing, my force. And if I find the x component, it will be positive because cosine is positive in that quadrant. F2 times cosine, and that angle was 27.6 degrees. Sine, on the other hand, will be negative. Negative F2 sine of 27.6 degrees. Now, if I add up all of these components, all the x components, and add up all the y components individually, I should end up with 0 because that object, that point in the middle, is static. So I'm going to go ahead and add these all up and make it equal to 0. So for my x components, my equation will be 950 minus f1 cosine of 41.5 degrees minus 1,917 plus f2 cosine 27.6. And that is equal to 0. Let me do the same thing now for the y components equation. Now some students feel comfortable evaluating cosine, sine, and so on. Although I'll just leave it this way because it's more accurate. Most often when you do evaluate this, you'll end up rounding too much, and this will throw off the final answer. So you can leave it this way. The constants in both of these equations is right here. And normally when we solve for a linear system, we like to isolate for the constant. So I'm going to subtract 950 with this number and subtract 1186 with this number first, and then take that number over to the opposite side. Let's find out what that is. 950 minus 1,917, that gives us negative 967. Bringing it over makes it positive 967. This part and this part remain the way they are. Similarly, combining these two, 1,186 minus 927, that gives us 259. Bringing that over makes it negative 259. And this term and this term remain the way they are. Now instead of doing this manually, and you can easily do this manually by using the addition-subtraction method, I'm going to use my calculator to find out what my f1 and f2 are. Now, not every calculator has this function, but mine does. The way you access it is you click Mode, Equation, number 5, and you click 1. That's to solve a linear system with two unknowns, which is exactly what we have here. And I'm going to substitute the coefficients of my terms. So pretend that this was x and this was y. The coefficient, the number in front, would be negative cosine 41.5. So I'm going to write down negative cosine 41.5, and that is my a. Similarly, I have cosine of 27.6 and 967. This is one of the reasons why I brought the constant over, because the calculator is programmed to see the constant on its own. So if it was here and I put negative 967, it would be wrong. Next we have sine of 41.5 and negative sine of 27.6, and our constant is negative 259. Pressing equals will give me force 1, which is 909. Force 1 is equal to 909 pounds. And force 2 is 1859. 1859 pounds. So to make this object static at equilibrium, this force needs to be 909, and this force needs to be 1,859. So there you have it. That is how to solve word problems with two unknowns.